So Venkat is one of my favorite speakers, and just by the numbers when he comes, I would say he's Denver Judd's favorite speaker as well. He always packs the house. He's great. Dr. Subramaniam is an author, a lecturer in a bunch of different spaces, including Java, agile, all sorts of great stuff. He also has Agile Learner, and he has a conference coming up. Just wonderful, wonderful stuff. And tonight he's going to be talking about the qualities of a highly effective architect. Do you have your, yeah, looks like your wife too, for your, all right, so I'm going to turn this off. And everybody give a big round of applause for Venkat.
Well, thank you so much for coming here. It's a great pleasure to be here at one of my favorite jugs as well. And I definitely want to give a shout out for the organizers, amazing group. So thanks, and also thank you for taking your time to be here. So I want to talk about something that we all are really excited about, being an architect. Some of us aspire to be architects. Some of us were architects at some point, and almost everybody works with architects. So I want to focus on the architect, and just to kind of set the expectation. I usually give technical talks, but this one is pretty much non-technical in nature. I'm going to focus on the person, the architect, rather than the architecture itself. So I want to talk about what does it mean to be a really good architect. Now, some people who have listened to this talk before have said, well, yes, it's useful for an architect, but it's also useful for just about anybody else, being a team leader, being a person who is a manager, anybody in the organization. So I want to just focus on how can we be better people in general, working technically. Best time to ask questions or make comments is anytime you have it, so please don't hesitate to talk. I'll also be more than happy to listen to you towards the end as well. Anytime is good. So I want to start focusing on the word architect to begin with. Now, when you hear the word architect, what comes to your mind? Unfortunately, though, for a lot of us, the word architect can be a little scary because of our past experiences. And one thought that may come to our mind is this kind of an architect, the one from Matrix. Here is the architect sitting on the other side, and he's getting himself introduced. Now, this reminds me of an experience years ago that I was in a conference, and we were in a Birds of Feather session, and I co-hosted it with my good friend Glenn Vanderberg. And the very first question from an audience was, what is it being an architect, and how do I get ready to be an architect? And as soon as this question was asked, almost instantaneously I blurted out saying, I hate architects. And the minute I said this, as I was winding down my statement, is when I remembered my good friend Glenn was a chief architect in a company. So I took several steps away, just in case he's going to throw a punch at me. And Glenn kind of gave me a stare, and then he said, I'm a chief architect in the company he was working for. And then he said, I also hate architects. I was much relieved at this point. But he didn't stop at that. He went on to say why he hates architects, even though he was one of them, or he was an architect at that time. Well, then he pointed to a wonderful article, and I often refer to this article. This is an article I not only read, but I actually reread it. So I encourage other developers to, who have read it, to reread it, or if not read it, to read it. And it's a very easy reach. Just Google for these words and you'll get it. And it's called Who Needs an Architect? It's a beautiful article. It's only 3.5 pages long by Martin Fowler. And I'm not going to talk about this article because I don't want to spoil the thrill for you to read it. It's actually a fun read. And you'll enjoy reading it and sharing with other people. So Google for Who Needs an Architect, you'll read it. But one of the things that he mentions in that article is he asks for a definition of architecture. And one of the definitions Martin Fowler gives, and also says that he hates this definition, and I hate the definition too, is he says that architecture is, creating things that are really hard to change. And the reason I really hate this definition is I am really good at creating things that are hard to change. And then I can celebrate that I've created architecture. So that's not a good definition. But then he asks other people for definition, and one good definition is from Ralph Johnson, as you would know, the author of the famous Design Patterns book. And Ralph says that architecture is a shared understanding of the most essential parts of a system. I really like this definition. And the reason I like the definition is not because it's an essential part of a system, but the word I like the most in there is the shared understanding. What that really comes to me is that it is not something that's esoteric. It's not something that's kept in ivory tower. It is something you want to be in a common place. Everybody should be dealing with this. And so in that regard, I want to really focus on the person, the people, and the team when it comes to architecture. So the question really is, what are some of the qualities of a good architecture? What are some of the qualities of an architect that we could really focus on in terms of how we can create such architecture? So I want to start with the very first one here, and that is be a mentor, not a tormentor. Now, it's very easy for a lot of us to forget where we came from. There was a time, looking around the room, I see a lot of experienced developers in this room, but it's easy to forget those years when we were green behind our ears. We asked all those stupid questions that others ask us today. And it's easy to forget this, and then we can kind of get ourselves in a mode where we know stuff and we can become impatient, really, helping other people to get better at what they do. Now, this reminds me of one experience I had. I'm a consultant, so I travel around a lot. I would go to a company, work with them for a week. I would go off to another company. Maybe 2 or 3 weeks later, I'll swing back to do some more work for them. And in one of those opportunities, I came back to a team, and one of the developers said, "Hey, Venkat, I wrote down a list of questions for you. I've been holding on to them until you came back to ask you. Can you go over them?" So we sat down for a good hour or so. We went through the questions. And then when I was done, I asked the developer, "Hey, these are really good questions, but I'm really curious. Why did you really write these questions down and wait for me? Because the architect over there knows every single one of these, and I can tell you that he knows it better than I do. So had you asked the architect, you would have gotten better answers, and you've gotten them sooner as well." And the developer looked really surprised and said, "You mean I would go ask him?" And I said, "Yeah, why wouldn't you ask him?" And the developer said, "Well, because every question to my architect starts with an answer, 'Are you stupid?' So we never really go to the architect and ask any questions. And this is like having a great food in front of you and having indigestion. What a sad, way to live when somebody that you work with is knowledgeable but totally unapproachable. So it's extremely important for us to be really that a mentor in the teams. And in fact, I would say it's our professional responsibility. Nurturing the people around us is everyone's professional responsibility. Now, having said that though, there is one thing we need to be careful about. I'm a huge fan of this win-win situation. Now, not everybody is Mother Teresa. We're not going to be doing things because it's for the greater good. So the question to ask is, what's in it for me if I'm going to be mentoring somebody else? And that's a really fair question to ask. So when somebody is being mentored, the mentee definitely is gaining from these mentorship. But what about the mentor themselves? And I'm absolutely to the firm belief that knowledge is one of the things that truly grows when it's given. So if I give you $10 right now, I'm going to be poor by $10. But if I give you the knowledge I have, I'm going to be richer in that knowledge as I give it to you. And so would you as you give it to other people as well. And the reason for that is, one of the beautiful things about knowledge is it comes in layers. In a way, I would say knowledge is kind of like onions. And of course, everybody who has peeled onions know there are more layers of onions to peel. But peeling onions is an act where we tear as we peel it. And that's how it is very frustrating as we start learning things. We realize there are more layers to peel as we go through. But one of the beautiful things of sharing knowledge is, I might sit next to somebody and maybe explaining something, and they don't even have to say anything in words. Their face immediately shows they are thinking, what in the world are you talking about? And immediately you realize you did not understand it as much as you really understood it. I remember this one experience I would never forget. I've been teaching for, a few years. This is even more worse in that regard. Maybe 5-6 years of teaching this particular course. And there was that night I was teaching this in the class, and I explained it, and absolutely nobody got it. I mean, I could see everybody's face. They were like looking at me, it's like, what are you talking about? And then I said to them, you know what, never mind, drop this idea. I'll come back and talk about this again the next time we meet. And then I went back to home that night and sat down and said, why did I have such a hard time describing this idea that I've been teaching for a few years? And that's when, shockingly, I realized that I really did not understand what I was teaching. So I spent about 5-6 hours that night researching this. And finally, I went back to the class and I was teaching this. And everybody said, oh my gosh, this is so simple. Why did you have so much difficulty explaining it last time? I said, oh, that's very easy. I know exactly why. Because I had no clue what I was teaching. And so this is a very rewarding experience, in my opinion, because knowing that we don't know something is absolutely phenomenal, because it gives me that enthusiasm to go learn and get deeper at it. And that's one of the benefits of really sharing knowledge, is we get better and deeper with it as time goes on. So being a mentor is something we should really strive for. That's our professional responsibility. Well, the next thing I want to talk about here is something we all can use very well, is to criticize ideas and not people. It's very easy for us to get carried away, and we could quite quickly turn into a conversation into a personal attack, and even without realizing that that's what we are doing. And we may not realize communicating it, but the receiver of those words may not really be, sensing it the way that we perceive it in a discussion. Now, I'm not perfect by any stretch of imagination, but I'm really trying hard to get better at what I do. And one of the things I've been trying to do is to use the word we more often than the word you. So rather than saying, let's look at your design, let's look at your design idea, instead of we can talk about, hey, let's talk about the problem we are solving. Let's focus on what we could do together to achieve this result. So we are taking the focus away from the person and instead focusing on the problem we are trying to solve. Now, I remember this one experience I had. I was a junior developer back then, and I was trying to explain a design idea to my supervisor at the time. And right in the middle of my discussion, my supervisor cut me off and said, well, if that's your bright idea, I feel really sorry for you. And I was not very happy hearing this. I kind of sat back and said, why don't you enlighten me how the design should be done? I'm all ears. And my supervisor went on to explain how design should be done. And I just waited for, the supervisor to keep going until that little, a point in the design discussion where there's no return at this point is completely messed up. And I waited for that opportune moment, and then I said, well, if that is your bright idea, now I feel absolutely terribly sorry for you. And he got extremely angry, kicked the wall, screamed for a few minutes. And then I said, how does it feel to throw stones at each other? Or can we focus on really learning and getting better? We became really good friends after that. And the point really is that we sometimes really lose track of the main issue, and then we divert attention towards people instead of focusing on the problem or the ideas that we are discussing. Now, obviously, one of the key things is to really look for how decisions often get made. Unfortunately, a lot of times, we make decisions not based on technical merits, but unfortunately based on emotional decisions. Oh, I want to use it because I love it. Or I want to use it because I know it. Or I want to use it because we used this on a previous project. And none of those ideas or discussions really are valid. And we need to really rethink about how to really bring discussions into the matter at hand. So how do we really get better at doing this? Well, one technique that might be helpful is to really realize that everything is full of trade-offs. Now, that's what we do. Our profession is full of trade-offs. There are no absolutes. Your thoughts, your ideas may be really good today, but those may not really be valid tomorrow or day after in a different situation or different context. And it's all about trade-offs. Something is better today, the same idea may not be better tomorrow, and we got to be able to evaluate this back and forth. So one way we can really address this is using a technique called debating with knives. So the idea of debating with knives is, imagine we are sitting in a round table for dinner, and imagine that we have, of course, the utensils in front of us, and I'm going to put my knife facing away from me, and then let's say Greg is sitting at the same table. He's going to put the knife facing towards him, and so will everybody else on the table, alternating position of the knife. I put it facing away from me. The person next to me puts it facing towards them. Now, let's say the discussion really is whether we should use angular or react when the real answer is view. But the point really is we want to have this discussion whether we should be using one or the other. Well, because the knife is facing away from me, I'm going to speak everything possible to say Angular is not a good idea. I'm going to say Angular is bloated. Do you even remember what happened to people using Angular 1? Their scars are still really, bleeding. And of course, Angular is heavyweight. It's a monster. It takes a lot of time to learn. Yada, yada, yada. I'm going to keep going with it. Greg, on the other hand, because the knife is facing towards him, he's going to say, oh, come on now. Angular is awesome because it is a MVC framework. If you really need to do powerful things and our application requires a lot of heavyweight lifting on the UI, this is really great. Once you go through the learning curve, it's going to give you the mileage. If you were to use React, you got to keep pulling in so many libraries. It's going to drive people crazy. We're going to go through this conversation for a while. At some point, when the conversation kind of winds down, we're going to flip the direction of the knife. Now it's facing towards me. It's facing away from him. We need to start talking on the opposite side. I need to start speaking in favor of why Angular may be a really good choice, and Greg needs to start in a conversation about why Angular probably is not a good idea. If a person cannot speak on both sides of an issue, there's a nice word for it. That's called bias. And there are people biased towards something. There are people biased away from or against something as well. And both kind of biases are really bad. And in fact, there are times when you ask somebody, what do you think of it? And they say, I hate it, and hate it. Well, that's clearly a bias. Or similarly, the person who says, I love it and there's nothing better than this. Both of them are really biases. I remember working in a company as a consultant where I asked them, how did your entire company decide on this one language as the right language? And the VP kind of laughed and said, oh, that's a very easy question to answer. This happened a few years ago when people were so biased towards a technology, they framed all the questions in a way the answer will be that language, and they came out winning, and now we are suffering with the decision they made. So that's something really important for us to keep in mind. I was mentioning this in a talk where I had a good friend of mine, and he emailed me a few days later, and he said, hey, Venkat, I really want to thank you for this idea of debating with knives you talked about in your talk. And he went on to say that he used to have a lot of arguments with a lot of different people, and including his own family and wife. And then he said that he decided to use debating with knife, and he said that things have calmed down a lot better, and he's more rational with these discussions. I replied to him saying, I'm really happy to hear it, but I did recommend to him that when he's doing this at home, not to really do it with the real knives. I don't want this to lead to any domestic violence with my friend. So the point really is that we can actually have a good conversation, an objective conversation on both sides, and there's really good benefits for doing it. Well, the next thing I want to talk about here is to guide and don't dictate. Now, we are all under a lot of pressure these days. We have to deliver software. We got to deliver solutions. We go to work and there's always people asking, are you done yet? And so when you're an architect, when you're a team leader, when you are focused on delivering results, you might eventually get to a point where you're like, I don't have time for this. I'm going to walk in, I'm going to tell people what to do, I'm going to give marching orders and let them really get it done. Well, unfortunately, that mode of operation is extremely detrimental for several reasons. So it is important to guide the team of developers so they become smarter and they can improve and figure things out rather than us dictating how to do things. And that is something we need to really motivate. One of the benefits of doing this is we suddenly feel like we are beginning to work with a mature team of developers. And the worst part is when we come into work and get really agitated because we feel like a lot of people around us are not very competent, but maybe they're not competent because we never gave them a chance to become really competent. So what if we can give them an opportunity to discover, to learn, and get better? Then we realize we don't have to work that hard. We got smart people around us to really do the job for us. It gets really better. And this is one of the things I want to emphasize. I do have to say there are two kinds of people in the world that scare me the most. The first one are the ones who cannot follow instructions. And the second one are the ones who can only follow instruction. Both of these categories are dangerous. The first one, you give them instructions and you go for lunch and you come back and they're still stuck where you left them. And you're like, why can't you follow these instructions, get this done? Well, they can't follow what's been given. Even worse are the people who take your instructions, get it done, and they tell you that it absolutely failed. And then you're like, well, in step 3, you should have done something different. But that's not what you said. Well, you want people to really take the charge of situation, use it as a guidance, not a prescription, and be able to go back and discover things and do it. And that is something absolutely important for people to get better at what they do. But there are some really good benefits for this approach from our point of view as well. And that is, you may discover things from this experience as well. So I remember this one experience. A junior developer came into my office and said, hey, I'm trying to solve this problem. Can you give me some suggestions on how to solve it? And I said to the developer, don't worry about the solution. Let's talk about the problem you are trying to implement. So we spent, some 10, 15 minutes talking about the problem. And all of a sudden, not only did I understand the problem, the developer understood the problem a lot better as well. At the end of the discussion, I said, well, now that we have a better understanding of the problem, why don't you go off, try to find a solution for this. Don't spend too much time on it. Give it a try. And if you find a solution, that's great. And if you don't find it, don't waste your time. Just come back to me. I know exactly how to solve it. I will give it to you at the time, but not now. And so I sent off the developer. And about maybe 15, 20 minutes goes by. I was walking down the corridor and I saw the developer coming in front of me, and he said, oh, by the way, really thank you for the discussion. I understood the problem a lot better, but I went back and figured a solution. And I said, oh, that's awesome. Can you tell me what you did to solve the problem? And he went on to explain how we solved it. And I said, oh my gosh, I'm so glad I did not tell you how to solve it, because what you did is way better than what I knew. And I ended up learning from this experience. And that is one thing I'm really selfish about. I know how to solve a problem, but I'm not going to tell you that because I want to know if there's a better way that you can show me. And I would rather be the person learning from that experience. And of course, if you cannot figure it out, we might as well go with the solution one of us knows. So just a little bit of opportunity can come out winning by learning something in that process. We can discover and learn something along the way as well. Well, that brings us to one of the other things I care a lot about, and that is to practice collective ownership. Now, we live in a very difficult times today. I remember being in school several decades ago, and it was, yes, I found it hard like anybody else does, but looking back, I would say that was easy because I had to know one thing, and I was the king of the world knowing that one thing. Look at the kids graduating today. They have to know everything and still some more. And by the time they come out and they go for an interview, there are 20,000 frameworks on JavaScript. How do you ever deal with this situation? A lot of stuff we need to know keeps on increasing. It's just overwhelming. So one of the things people often tell us is, oh, you got to become a specialist. And I would be honest about it. I am not a specialist at all. I am going to say I'm more of a generalist than a specialist. I feel weak if I have to focus on one thing because my worry is I'll become obsolete very quickly if I know that one thing. And I always say it's not important to be employed. It's really important to be employable. And how do I become employable? Well, I got to diversify my knowledge portfolio. I got to know different things. So should I be a specialist or should I be a generalist? My argument is both of those are failures in my opinion. Somebody who's a specialist is going to become obsolete when that one thing is now no longer relevant. And somebody who's completely generalist is pretty useless. So I think we need to be both. You need to really be a specialist in some areas, but you also have to be a generalist to a broad area that you can actually pick up and become a specialist when it's needed. So in that regard, I'm a huge fan of being a person who can do multiple different things. And I remember this one experience. There was this very young developer, amazing developers, and my job for this client, this was a major bank in Holland, and I went there to be there for a few months to work with this team, and I was a coach really pairing with developers and working with them. And I remember this absolute fascinating day. We're sitting down and we were supposed to implement a feature for this banking application. Say, for example, we had to create an account. So I sit down with this developer. We wrote tests and we wrote code for the backend. And now the code for the backend works. We can, issue a little, query to the backend and we can create an account. As soon as this test worked, the developer was very eager to announce, oh, this is great, we are done. I said, oh my gosh, what do you mean we're done? He said, look, the test is passing, the backend code is done. It is done. I said, no. The word done is a very, a difficult word to use so easily. We're not done. We're far from being done. We still have to write the UI. And the developer said, oh, no. That's never going to happen. I said, well, what's wrong with writing the UI? He's like, are you crazy? No way. There's nothing can pay me to touch that stupid HTML. And I said, oh, is that so? Well, guess what? We are in charge of implementing this feature. We implemented a narrow slice on the back end. We are going to implement the front end. So we're going to start with HTML and JavaScript. He said, you can do it, but I'm not going to do it. I said, all right, here's the deal. If you don't know how to do it, we're going to learn how to do it. If you don't want to do it, right now, you and I are going to walk over to the boss and going to have a very long discussion. Your choice. And he was absolutely, I could see the change in his face. He's like, fine. And then we're sitting and writing code. And, they usually leave home on time. 5 o'clock comes around. He picks up his stuff, leaves. And, I'm in this foreign country. I have nothing else to do. I sit there and work for a few more hours. Well, the next morning I was back at work early. I'm sitting and working. And he walks in, throws his stuff on the desk and says, Venkat. I'm like, oh, yes. He said, I'm still mad at you. And I said, oh my gosh, I didn't even know you were mad at me when you left. Had you only told me we could have resolved this last night, I can't imagine you being awake all night being mad at me. How terrible that is. And then he kind of said, and why were you mad at me? He said, because you made me touch HTML. And then I looked at him and said, and he said, it's not that bad. And then we sat down and we paired again, we programmed, and he moved on to become a full stack developer eventually. But the point really is, we have this in our mind. And I know it because I was him only 30 years ago. I used to walk arrogantly, so happy that I was so good at what I did, and anybody else who did anything else was a low life form. And I then woke up one morning and realized, oh my gosh, I'm so ignorant about a lot of things. If somebody came to me and said, how does that work? I'm like, I don't care. But it's not that I didn't care about it. I was so ignorant, and I realized it's never going to help me. And I promised myself as a young developer that I'll be more of a generalist than a specialist. And I think mostly have kept up with the promise over the years and worked on to diversify my knowledge portfolio. Well, from an individual, this is extremely beneficial, but what about from the company's point of view? Well, one of the things to consider is to reduce the truck factor. So what is the truck factor? Truck factor is the number of people on your team who should be run over by a truck for the project to fail. Unfortunately, this number is 1 on a lot of projects. There is one developer who codes a particular module, and this person, dies, and the entire project fails. This actually happened on a project, but it was worse than death. This particular developer who wrote this module and nobody else touched it, won a lotto. He comes to work one day and says, I'm a millionaire and I'm quitting. And the project failed. And everybody hated this. They would have been happier had he died in a truck crash than to be a millionaire, in fact. But the point really is, this can be a disaster. Well, this reminds me of an experience. I was in a European country. I won't be too specific about it because I've mentioned the country name. You will know the company name. It's that popular in that region. And I was working with this particular company. They have 70,000 people working for this company. And I was a consultant. I was sitting in a room, and the project manager is sitting on the left side, and 2 developers are kind of sitting where you are sitting. And these 2 developers this manager is saying, I want either both of you or at least one of you to come and spend time on this new project. And the 2 developers are like, nope, we can't do it. We are working on this project. We cannot take any time away from this project. And I kind of looking at this discussion, and this is going back and forth, and after a while I said, excuse me, pardon me if you don't mind me interrupting. And I stood in front of the developers and said, could you please explain to me what you do? And the developer on my left side said, I work on 1/2 of the application. And then I looked at the guy on my right side and said, could you tell me what you do? And he proudly said, I work on the other half of the application. And he never touches my code. I never touch his code. And I said, interesting. With all respect, imagine you walk out today and you get run by a truck. What will happen? And he said, he dies with me. And this is kind of like scary, isn't it? So you have 70,000 people working in the company, and only one person, leaves, and the entire project will collapse. But we see this all the time. Sometimes programmers take territorial ownership on code. It's as if they left their scent on the code and nobody else can go near that code. This is kind of crazy. And I'm a big believer in collective ownership. Anybody who's willing and capable and can take responsibility should be able to go ahead and modify the code as long as they can explain what they are doing and continue to move forward. Now, there is a benefit to this from the team point of view as well. If I'm a project manager, very ill-informed project manager, I'm going to look at Greg and say, gosh, Greg writes database code really nicely. I'm going to give more database work to him. Well, guess what? He's going to get really, really faster as time goes on. I'm going to say he's going to write the UI code from now on, and nobody else is going to do that. Well, guess what? The manager is going to sit there and say, I'm awesome. Look at the speed my team is working with. That manager is kind of like the turkey the week before Thanksgiving. Because you go to the turkey and say, how are things going? And the turkey says, really well. In fact, they've been feeding me more recently. You kind of wonder why. Well, if one of the developers were to quit, it comes to a grinding halt at that point because nobody else can understand the code. With all respect, if nobody has ever looked at a piece of code, then nobody else is going to be able to understand it. I know only one way a code can be made readable, and that is to ask a colleague to read it. If nobody else has read a piece of code, then we have absolutely no claim towards a readable code. In fact, this happens quite often. Even the very person who wrote the code doesn't understand the code after a while. Like the other day, I saw a developer kicking and cursing on a piece of code until he realized he was the author, didn't remember it. It's not that bad anymore. Well, the point really is when we don't have collective ownership, we are increasing the speed in the short term with a huge risk for the long term. Versus if we have a collective ownership, we may be a little slower in the beginning, but we accelerate and get better over time. Now, clearly, I'm not suggesting that I'm really good at everything I do. It's far from the truth. However, I don't have to be really that good to start writing some database calls. This is exactly what I do most often. I would write the database queries. I would get something working. I have unit tests written on my code. Then I would go to a person who is better at database and say, hey, let's pair up and improve this code. And we'll spend an hour and optimize the code and make it better. And that is exactly what I want to do, is to get things moving and then bring other people who can improve that part of the code, and we both can learn along with the experience and move forward. Now, the next thing I want to emphasize here is to allow developers to figure it out. Well, I talked about guide and don't dictate, but this is a little bit different than the guide and dictate, because in the guiding and don't dictate, we have a problem to solve and we maybe are eager to tell them how to do than letting them figure out. This is quite the opposite. A developer may be really keen in figuring things out, and we need to really give them opportunity to figure this out. I'll share with you one experience I would never forget, and this is where I think part of the beauty of we working together is not only that we learn technical things, we also have the opportunity to learn from other people as to how we can be better people as well. So one such experience is, I had this opportunity to work on a project with a gentleman some of you may know by the name of Stuart Halloway. And Stuart Halloway is the CTO of a company called Cognitech. They are the company behind Clojure language. He used to run a company called Relevance back in time. But Stu and I have known each other for a long time, but I had this absolute wonderful opportunity to work on a project on his team. And this project had started maybe 6 or 7 weeks before I went down to work with them. And this was probably the second day of the project. And I started implementing a feature, and I went down to Stu and I said, hey Stu, I'm looking at this piece of code, and I think there is a better design than the design that's in place for similar features. Well, Stu could have looked at me and said, Venkat, why don't you shut up and go back to your desk and work, because we've been doing this for several weeks now. Instead, Stu said, oh, really? Why do you think that design is not good? What do you have in mind? And I blurted out a few ideas. I said, here's why the design is not good. Here's why this alternative design would be better. And then instead of rejecting my thought, he said, how much time do you need to maybe play with it and see if this is a better idea? I said, oh, I can do this in an hour. And immediately Stu said, your hour just started. And I said, that's awesome. I'll be right back. And I went to my desk And I was so absolutely pumped up because this is great. He didn't reject my thought. He gave me the opportunity to go experiment. I'm going to prove how wonderful my design idea is. And I sat down, I started creating a sample for a few minutes. And 10 minutes later, I went back to Stu and said, hey, Stu, I'm done with my little experimentation. He said, that was quick. What do you have to tell me? I said, I found that I'm stupid. And he looked at me and said, well, that's not what I was hoping for. Now tell me what your experience was. What did you find out? I said, well, here's why I think the design idea I had was better. But when I started implementing, I realized that there are these other concerns. And I realized that this will not work really well. Even though that design is not really that optimal, I think it can solve the problem better. So it's a trade-off, and what you have is better than what I thought would be better. He said, you know what, I really like the idea you had as well, and had it worked, I think that would have been a better solution. Darn it, it didn't work this time, but we should never give up, we should keep trying. What do you want to do now? I said, I'm going to go implement the feature now. And that is one thing I want to emphasize is, you cannot expect people to agree with you all the time, but what you want is a good alignment in a team. And you want people to support the ideas even though they may not have come up with it. And at this point, I was absolutely aligned with it because I was given the opportunity to try something different. And that is absolutely motivating, and loyalty is built in because the team is not out to get you. They are there to help you to build yourselves as well. And that's a very positive environment to work in. And that's an experience, even though it's been a long time now, I would never forget that. So, but in that regard, there is one thing we tend to forget sometimes, but I try to remind this myself quite often. It should be absolutely safe to be honest. And honesty is extremely important. So for example, let's say I'm standing by the water cooler, you come along, and I'm going to tell you, hey, you know what? Yesterday, I had a design discussion with Joe, and I cannot imagine how they hired Joe. He doesn't even know the stupid things. And how are we going to even build software with somebody who is that ridiculous? When I'm talking all about Joe to you, you're not thinking, gosh, this Joe is really terrible. How did we hire Joe? You are thinking, wait a minute. If this is what Venkat talks about Joe in front of me, I wonder what Venkat tells about me to other people. So what I've told you in this discussion is that Venkat is not really safe to be honest around because he is going to keep talking about you to other people. And this is something I want to really emphasize is you really want to build a team. And one of the ways to do that is to be extremely positive and motivating and supportive. I'll be honest about it. You know, I have this absolute privilege of speaking in front of thousands of people every year. And I go and give talks. And when I give talks, I want to talk about people who are way better than me, who are knowledgeable, who know things. As an example, purely as an example, let's talk about Brian Getz. Well, Brian Getz is the chief architect of Java. He is the one who has implemented Lambda expressions. And I give talks, and often Brian is in the room listening to me, and there are literally, 1,000 people in front of me. And when I finish my talk, Brian claps his hands and says, that's an awesome talk, Venkat. That's what he says. And then I would get a private email from him. And then there'll be a list of places where I suck. And then he would tell me, here's where your logic is absolutely flawed. You need to fix it. And every one of those private emails I get from Brian is he's not teaching me technical things. He is teaching me how to be a better human. Because Brian doesn't sit there among 1,000 people and say, hey, you moron, I'm the one who wrote this stuff. Let me explain to you how this works. Instead, he kind of listens and says, that's a great talk, awesome. And then he sends me an email saying, by the way, you were wrong at that point, you need to fix it. And Brian is just one example I've used, but there are other people, absolutely honestly, I save every one of those emails because that's a learning experience for me. Not just in technology, but how I could be a better human in the future as well. And that is exactly what I want to do, is to cultivate teams of developers so they can get better, very comfortable, but at the same time also motivate and help them privately so they can actually get really better at what they do. It should be extremely safe to be honest. That's important. The other thing is, it's funny how some ideas go from brilliant to stupid within minutes of prototyping. This was a more recent experience for me. This was July of 2019. This was over the summer, and I was implementing an application where I had to deal with a lot of design decisions. And I remember one morning, I was sitting at my desk and I was trying to really implement a particular problem, and I just could not because it was really hard for me to think about how to do it. And I was desperate to look for answers. I was just Googling away. And then I came across one article, and that article described how exactly the problem could be solved. And I remember clearly looking at this article, I literally screamed. I said, "Oh my gosh, this is brilliant." And I immediately scanned through the document as patient as I am, get a gist of it, and I'm like, this is great. This author is amazing. I'd never thought of solving the problem this way. And of course, over the years, I've learned my experience never to do anything on production code. So I kind of left my production code alone, created a standalone prototype, and I started implementing this great idea. It took me literally 10 minutes. And then I heard myself screaming, "This is stupid." And I realized this was fundamentally a broken idea. This would not be useful at all. And I went back to the article, and the author had taken the time to explain how great it is, but never addressed the limitations of it. I'm like, never mind, back to the drawing board. And I spent the next few hours trying to figure out a solution for it. And of course, eventually I moved on and solved the problem. But that's one of the things I always encourage developers is when you think you have a bright idea, just don't celebrate it. Don't talk about it. Just do a prototype. And the minute you do a prototype, nothing brings reality to the forefront as the prototype we can create. That's a great learning experience. So build prototypes all the time. But always put a time box on it, just like what Stu did. He said, "How much time do you need for it?" I said, "An hour." He said, "Your clock starts now." Whether it's 30 minutes, whether it's an hour, whether it's 2 days, I've worked on projects where my bosses would give me 3 weeks to experiment something. It doesn't matter, but it's a time box effort. And you want to really put in a time box effort to investigate a particular problem. And then at the end of the time, you need to really move on with whatever you have. Life is full of trade-offs. Well, focus on outcomes, not on process. Now, it is quite possible that we all get hung up with process. We talk about how do you introduce change in companies? How do we motivate teams to adapt? And what are the process? How do we, go through sequence of steps? But one of the things to keep in mind is to focus on the outcome rather than on the process itself, because what we achieve in the end is more important than the route we take to get towards it. And when it comes to this, oftentimes I get this question a lot when I go to conferences. People often come to me and say, "Hey, the technology is great. How do I convince my manager that this is good? How do I convince my team this is good?" And I always ask them, with all respect, you are interested in convincing somebody, but can you tell me, are you really convinced yet? And they say, "Of course I am." I say, "No, that's called infatuation. That's far from being convinced." So you cannot be convinced by something yourself until you have actually prototyped something. This reminds me of an experience I had. I was in Pennsylvania. I was going to teach a course for a week in a company, and I show up at the door on Monday, and the manager comes and greets me at the door and says, "Hey, Venkat, thanks for coming. Your class is going to be on the second floor. The team of developers are waiting for you. But before we go to the second floor, I'm assuming you want to meet the people who are responsible for you to be here." I said, "Gosh, I thought I'm here because of you, because you called me and asked me to come here." He said, No, I'm the one who made the call to you, but you're here because of 2 developers. Let me introduce you to them." And he walks me down the corridor, and there's a room with absolutely no lights as programmers normally live. And, there's a dark room with the light from the computer, 2 guys sitting and coding away. And he said, "Those are the 2 guys who are responsible for you to be here." I said, "I'm really curious. Who are these 2 people? I apologize, I don't know them." He said, "Oh, no, this is great. These 2 developers came to a conference, heard you speak, and when they came back, it was like they were on fire. They had just found something. But they didn't come and tell us what they learned. They kind of hid themselves in a corner, and they prototyped a module of our application." Well, in their application, there were parts of code that was horrific. They could not maintain it. The maintenance cost was really high, and every time somebody touched the code, there were more bugs in it. Well, these 2 developers went back, prototyped that little module, and went back to the entire team and said, "We want to show you a demo." And they demoed their prototype and gave the team the prototype code and said, "Here you go, play with it, break it, learn from it." And if you like it, take it. And if you don't take it, we leave. And it's up to you. Because we're no longer going to work in this company on that stinking project you're working on. It's not our good use of our time. Well, the company was kind of in a shock that these guys discovered this and developed a prototype. There was not a whole lot to argue when you have a working solution in front of you and pros and cons listed because of the evidence. Well, they kind of went through it, had a few other developers evaluate it, and eventually they said, well, we're going to move in this direction. And they said, that's why you are here, to take the team forward in this technology, because we need to really get deeper into it. We're going to change our direction and start investing in this technology moving forward. And then that is one of the things is prototype beats any arguments we can make. So the worst way to convince a team that something is great is to tell them how cool it is, or how awesome it is, or even worse, how concise the code is. Nobody cares. And yes, you and I care about code being concise, but keep it quiet. The management doesn't care about it. The business doesn't care about it. And we need to really draw the value to them in ways that they can understand. And by prototyping, we're able to defend against those kinds of questions because we truly have taken the time to convince ourselves through these prototyping efforts, and that can be very, very useful. Well, it is important for us to gain domain expertise. Now, I know what you're thinking. You're thinking, are you out of your mind? There are 20,000 things we need to learn in programming, and then by the time we are done, there is more to learn. How in the world can I focus on learning about the domain? That's a lot of work, isn't it? Well, yes, it is, but unfortunately, that is our responsibility because we cannot become good in designing. We cannot become better in architecting if we don't understand the domain. Now, I'll speak about my own experience. I was absolutely, disinterested in chemistry. Chemistry class is what I would cut in school. I wouldn't bother to go. I mean, nothing wrong with chemistry. Just that was not my piece of cake. And of course, when I graduated, imagine what? My first job was to work with, chemical engineers. And these people would be doing formulas all day long. And these were PhDs in chemical engineering. It was nerve-wracking because some of the people I worked with were the people who invented algorithms in chemical engineering. And I was absolutely naive. I was in charge of architecting and designing. And I would go to these people, and I have to tell you, the best people I've ever worked with in my life, because they had no negativity in their minds at all. They wouldn't make fun of me, at least not in front of me. And they would always be genuine in answering. I would go to them and say, hey, I'm designing this piece of code. I'm thinking of implementing this design idea. What do you think? And in a very straight face, they would look at me and say, Venkat, if you ever do this, you will violate the law of physics. I'm like, oh my gosh, I'm so glad I asked. Or other times I would go to them and say, hey, I'm designing this particular concept over here. I'm wondering if I should also include it. And they would look at me and say, you're not wrong, Venkat, but that is true in general, but it would never be true for hydrocarbons. I have no clue what that means, but I'm so glad I asked. And apparently, had I made it extensible, I would have really made something work where it would never happen in nature. What a waste of code. And that is something we need to really be aware of. We cannot design in isolation. We cannot architect solutions in isolation. It's got to be relevant to the problem and the domain. If you're working in the financial industry, you need to understand the laws of financial world. If you're working for an insurance business, you need to understand what the rules of insurance are. And you cannot just design in theory. It's got to be relevant to those things. Now, one of the holy grails of software development is extensibility. Everybody wants to make code extensible. And when you write code, how many times we ask ourselves, is that extensible? I remember this one experience in Ohio. I was sitting in a room with a full team. The manager was in front of me. The entire team was in front of me. And the manager looked at me and said, hey, Venkat, I got a question for you. My team, it was a slogan every day. They will tell me, we are creating extensible software. And every time I ask them something, they would say, we are creating extensible software. So this extensible software was the mantra that you keep hearing every day. And then he went on to say, we released the product. Within a week, they came back with one change request, which came from our customers. And I went to my team and said, we got to make this small change. And my team said, we need a bit of a time to do it. And then he said, what does it mean they want more time to do it when they kept telling me it's extensible? And when I asked them why, they said they got to change that and 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 change that. And the list keeps on growing. I don't get it. What's going on? I told him, well, I know exactly where it went wrong. You are at fault. He said, I'm at fault. What did I do? I said, the software was extensible until you asked it to be extended. And if you never asked it for extending, it would still be extensible. And that is the myth we live in. So we create extensible software and it's beautiful and extensible until you don't ask it to be extended. And the minute we want to extend it, how many times we hear people saying, yeah, we got to change it. Why not? We didn't plan for it. Well, then what is extensibility if we didn't plan for it? Well, it turns out that there are three kinds of people. This is true in every company that you work in. There are three kinds of people. So who are these three kinds of people? The first kind of people are those who understand software design really well, but don't have a clue about the domain. That's me usually. And I can do software, but I don't have a clue what domain I'm working on most of the time. The second group of people are the people who understand the domain really well, but don't have a clue about software design. They may have written Fortran code back in school. They think they're experts in programming, but they're far from it. But the third group of people are the people who are really good in software design and have really good domain knowledge. I can pick these people with fingers in one hand. I remember their names really well after all these years. Now, if you are ever curious how to find these people in your team, it's really easy. When you're in a room like this, in your corporate meeting, quickly turn off the light. These are the people that glow in the dark. There are very few people in the companies. So most people in the company are 1 and 2. These very few people belong to the third category. I know what you're wondering. No, yes, we'll politely ignore that fourth category. Now, in this case, of course, when you have these very few people who actually are both good in software and on the domain, these are the people who can really make those extensibility decisions. But unfortunately, they are very far and few. Most of the organizations have 1 and 2 in it, and which means we absolutely have to collaborate. I, as a programmer, have to sit shoulder to shoulder and talk to a person who has the domain expertise, and we need to be able to come up with a solution collectively together rather than trying to make the software extensible in a vacuum or not understanding the domain in general. Well, when it comes to, as we get more experience, as we get really good at what we do, there is one risk we will get into. And that is, we are really good at learning. But it turns out, we really need to take the time to learn, not to just learn, but to unlearn. And unlearning is one thing that I'm realizing is what we sometimes fail to do as we get experience. There are times I would work with a really good experienced developer. They are absolutely capable, and yet they are really not able to adapt to some approaches or some practices. And I would kind of sit there and wonder, why is this smart person having such a difficulty adapting to this way of writing software or designing? And I would then realize it's not because they're not good at what they do. It's the contrary. It's because they are really good at what they do. They are so good at what they do, it's really hard for them to change how they do things. So it turns out we have to really take the time to unlearn. So learning is a relatively easy process, but unlearning takes a lot more time and effort. So one of the things I would ask people is not just what they learned, but what they actually unlearned in their experience. That would be a really nice discussion to have. Rather than asking people, hey, what did you learn recently? Instead, ask the question, what did you unlearn recently? And that would be a really good conversation to have. What if we deliberately put the effort to unlearn and change the way we do things is something we need to really think about. Well, as it turns out, unlearning is a very deliberate activity, and learning is more natural for us as humans. We do this all the time. Ever since we were born, we are learning things continuously. But unlearning takes a very conscious and deliberate effort for us to be able to unlearn. So take the time to unlearn before we can learn. And a lot of practices are really hard because we're trying to add something, but sometimes we have to replace something we know rather than to add it. And so unlearning becomes important. Diversify your knowledge portfolio. Now, we want to know different things. mentioned about being a generalist versus a specialist. Well, diversifying the knowledge portfolio is that effort to become a little bit more generalist than we are, and we want to really diversify the knowledge portfolio. There are several benefits to diversifying the knowledge portfolio. Well, the pragmatic programmer said we should learn at least one new language every year. What they actually meant, I would believe, is that we should really learn at least one very different new language every year. If you know Java, you can't count one language by learning C# because they're so similar to each other. And one of the languages you learn should be something very different from what you actually know. I often say, you know you're learning the right stuff when you're kicking, screaming, and cursing. And if that's not happening, you're not learning enough. I mean, what good is it to learn something new if it's not going to change the way you think and change the way you do things after you learn it? And it's extremely important to do that. Well, I'll share my own experience in this regard. My aha moment in recent years for this was two things. One was learning Haskell. And learning Haskell, I failed learning Haskell 2 times. And every single time I took it, I gave up and I walked away. And for the 3rd time I came on and said, gosh, why am I having such a difficulty? People I know and respect say this is great. I should really be taking the time to learn it. And when I forced myself to learn Haskell a 3rd time around, I can vouch for it. I don't use Haskell in production code at all, but the way I write Java code is different today because I know Haskell. The way I write code in Kotlin is different today because I know Haskell, because Haskell made me think differently. Another such language that blew my mind was Elm. Elm is called a reactive UI programming language, but the reason Elm blew my mind was Elm is 99% Haskell syntax and 1% F# syntax. But what's intriguing about Elm is Elm compiles down to JavaScript. I know that's very scary. I often tell people learning Elm, never open the file and look at the JavaScript. That's really scary. But what intrigued me was, think of Haskell. Haskell is like that cathedral. You walk in, you can hear the hymns, and there are people sitting there in harmony. That's how I feel about Haskell, right? It's a world of purity. And it's like being in a cathedral. Then you come over to JavaScript. JavaScript is kind of like this bazaar. Everything is everywhere. There's things on the floor. There is liquid flowing. There's a dog taking a leak near you. That's basically how it is when you are in JavaScript world, isn't it? But that's life. That's where we live. But then you write code in this cathedral language, and it somehow runs in this bazaar language. How is that even possible? But when I learned Elm, I stepped back and I thought to myself, oh my gosh, everybody had told me that UI has to be mutable. And then Elm is like, hold my drink. And I'm like, wow, that is amazing, because you're programming the UI with no mutability at all. And I just sat back and started thinking, I'm like, gosh, that is hurting my head. It's a very different way of thinking. And I'm not kidding with you. I, opened the editor and I wrote a pure JavaScript code with 0 mutability in it, just to prove to myself it is possible. And I was like, wow, I don't need to have mutability just to do UI programming. And I will tell you, today, I do JavaScript differently thanks to Elm. And then you realize, oh gosh, look at that Redux. Redux is doing things without mutability, very similar ideas to Elm. And that is one of the things that fascinates me, is our learning is really going across laterally. We can take some learning here and apply it over here and elsewhere, and we don't even realize where we are using it. In that regard, I'll give you one example of this. A beautiful keyword called yield. I came across yield, I don't know, maybe 15 years ago or so. I remember first time looking at the keyword called yield in language called Ruby. And I'm like, wow, this yield is intriguing. What does yield do? And I remember taking the time to learn about yield. A few years went by, I saw the yield keyword in C#. And now I was not asking, what does that mean? I was asking, how is it different from in Ruby? And one of the beauties of this is knowledge happens in deltas. You learn everything in Delta. Hey, I know yield in Ruby. How's it different from C Sharp? Then I saw yield in JavaScript. Then I saw yield in Kotlin. Then I now see yield in Java. And when you see yield in Java, I'm like, gosh, there's a yield in Java now. How is it different from the one in Ruby to JavaScript to C Sharp to Kotlin? How are these different? How are they similar? We tend to really pick up these things. And that's one of the benefits we see quickly. The amount of time we learn something new is inversely proportional to the number of different things we've learned in the past few years. The day I tweeted this, I remember very clearly. I was teaching a class, and it was a room full of developers, but there were two people right in the middle of the room, and those two people really made me think about this and tweet this. And these two gentlemen were absolutely fascinating. They were about the same age, about the same years of experience. They both at the time were older than me. I think they still are. But those two people, the one on my left side programmed in 6 or 7 different languages. The person on my right side programmed only in one language. And I would introduce a concept in the class, and I would hear a noise simultaneously from both of them. The one on my right would look at me and say, "Why are you doing this to me? I was so happy programming in this language I know, and you are showing me all these weird concepts. What am I going to do with all this?" The person on my left would be, hey, excuse me, can you back off a little bit? Can you go back and write this code a little differently? I want to compare to how this behaves to OCaml, or how it behaves to. And he was interested in comparative analysis, and the way the same idea was absorbed by these two people were completely different from one another. It was really fascinating to see this particular experience, and that's when I realized the amount of time you're going to take to learn something new is inversely proportional to the number of different things you have learned over the past few years. It's really coming back to this mental muscle. If I'm sitting on a couch and watching TV for 7 hours a day, and you come over and say, "Let's go jogging," I'm going to say, "Why don't you get me another can of soda and you go jogging an extra mile for me?" I'm not going to be able to do it unless I keep myself physically agile. Well, that's exactly the point about mental agility as well. The more we look at different things, we are quicker to learn something different and new. The fewer we look at different things, the harder it is for us to adapt. So keeping the mental muscle active is extremely important. Not only that, this also has yet another significant benefit as well. And I was blown away by this research. This was a research from the Chicago area. The researchers wanted to study the behavior of children. These are toddlers, and they wanted to see how the toddlers, perceive and communicate. So what these researchers did is they had objects, let's say, apples, and they would bring up apple. Imagine for a minute that I'm the researcher, and where Greg is sitting, let's say, is where a toddler is sitting. And what the researchers would do is to put 2 apples here in between the 2 of them, and they'd put an apple right behind the researcher. And they would ask the child, the toddler, "How many apples do you see?" Well, in the study, they conduct this interview for several children. But these children were grouped into 2 categories. One group of children were only exposed to one language, period. And all they knew was this one language. All they dealt with was one language. The other group were children who were exposed to multiple languages. These children did not speak multiple languages. These children had parents who spoke one language, but they had a nanny come over who spoke a different language. Or they had playmates at school where the children spoke other languages. And so they had these 2 groups of children. And when they asked the question, "How many apples do you see?" they were fascinated by consistency of the response, which was different between the 2 different categories of children. The children who were only exposed to one language ever, they would say, "I see 3 apples," for example. The 2 that was in between them and 1 behind the person asking the question. But when they asked the question consistently to the children who were exposed to multiple languages, these children would quickly glance around the room and they would always say 2 and not 3. And they were like, "Gosh, this is amazing. Why are the children not talking about the fruit behind them?" And it turns out the children were trying to think in terms of the person asking the question rather than in terms of themselves as they're observing. In other words, they tend to become a little bit more empathetic, seeing things from different people's point of view than their own point of view. I'm not absolutely an expert in anything, leave alone natural language, but as a person who has experience with multiple languages, I can vouch for that. When I knew one language, I was the most arrogant person in the world. And when I learned multiple different languages, I quickly realized there is no one way to solve the problem. And I'm really interested in exploring multiple different solutions now. So when developers come around and say, hey, I've got a different idea, I want to know what it is, because there are better ways and different ways to solve a problem. Well, one of the key things about being a really good architect, I cannot emphasize this enough, is to lead by example. I can't tell you how often I go to companies and architects do not do things they expect their teams to do. It is nerve-wracking to watch this. As one example, I've seen so many architects tell their team, you should write automated test. And the team is like, really? Can you show me how? No, you should write automated test. Well, because they never know how to write automated tests. They don't have a skill to do it. And how could you expect teams to do better quality work when you don't have a clue how to do it yourself? Well, yes, as a manager, I would say that's quite all right. Because you can say, I'm a manager, I just don't do anything anymore. You need to really do it. That's perfectly acceptable. But as not an architect, and as an architect, you need to be able to roll up your sleeves and show people how to do it. In fact, I once visited a company where the company is trying to bring in automated testing when the architect hated automated testing. How could you really influence a team of developers to get better at something when you not only competent with it, but you actually are against certain ideas and principles? Well, leading by example is extremely important. Well, as it turns out, one of the things to keep in mind is, I'll share with you one experience I had. This was a company in the middle of our country. I won't be specific about it. Their VP of R&D called me and said, hey, Venkat, come over. I need your help. And he said, they have 7,000 programmers every day coming to work and using a 15-year-old technology. And I said, gosh, why are they still using the technology that nobody wants to use anymore? And he said, oh, very simple. It's because our architects will not permit them to use anything else. And I was curious, what do you mean architects? Well, in this company, they had an architectural committee. And that committee contained 50 obsolete architects. And this group of architects were more powerful than the mafia. You couldn't do anything in this company if they did not give you the blessing. The VP didn't have power over the architectural committee. And then he said, they have written a document and they have said, here's a reference implementation. And every team has to take the reference implementation and implement it. If they ever do anything different, the corporate police will punish them. And he said, come help me. And when I went there, I learned a very important lesson. And that is, in organizations like that, the architectural committee is where innovation goes to die. If you ever have an idea, take it to them and they will kill it for you. And that's exactly what these 50 people were doing. People would go to them and say, I got a bright idea. And they were like, really? And that's it. It's dead. Or if it's not dead, by the time they even look at it, the technology has moved on. And it's scary when you have people who are... So the question is, don't we need a committee? And I want to emphasize this. I am not a fan of let the inmates run the asylum. That's not my idea. I'm not suggesting, oh, let the developers loose, let them do whatever they want to do. But I want to ask a simple question. Standardization is extremely important, no doubt about it. But I'm going to ask the question, has standardization led to stagnation? If standardization has led to stagnation, that's a very dangerous organization to work in. So I want standardization, but I want to evolve the standard very frequently and not become stagnant over time. That is something we need to really work towards. So in that regard, how can I be a better architect? Well, one of the things to really think about is to lead by example. Now, We can learn a lot from other humans, especially from children, but I remember this experience. My children are much older and grown up today, but when they were really small, young children, I remember I travel a lot, so I wanted to be the dad who can be, occasionally at least. So on one of my trips home, I, told my children, well, before you go to bed, you got to brush your teeth. And they looked at me and said, really? Why? As children always ask. Well, I give them a lecture. Well, because it's hygienic. If you brush your teeth before you go to bed, you don't have bacteria or when you sleep, yada, 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 and motivate all of that. Well, that's great. Awesome. Dad dispenses wisdom. I got to go brush my teeth. It worked really well for exactly one day. And the second night, of course, they're getting ready for bed. Hey, let's go get ready for bed. Oh, you know what? I don't want to brush my teeth today. Well, what happened? Don't we know that it's better to be hygienic? Yeah, but I'm tired. Okay, fine. You're tired. You don't have to brush your teeth today. All right, can you read a book for me now? Oh, you know what, sweetie? You go to bed. Be ready. Daddy's going to go brush the teeth before I come back and, help read the book. Oh, you're going to go brush now? Okay, I'll also brush now also. And they kind of follow you and start doing it. Now, this is not just true for children, honestly. I am the laziest person I know. And, it's good to go on walks. It's good to do exercise, all that. And, I have a nice meal and I sit on a couch. I'm like, oh, this is so comfortable. And we're supposed to go for a walk, but that can wait for tomorrow. And my wife would come along and say, let's go for a walk. I'm like, well, can we? No, we're going for a walk now. Yes, ma'am. So the point is, when you have a partner who can join you to do things, there's not a single point of failure. This is exactly the point I say about developers, architects, is if you're an architect, just don't expect your team to do stuff, do it with them. Not too long ago, a couple of weeks ago, I had an architect come to me and say, you know what, all these ideas are great, but, there's always this but I am really busy. I've got to do architecture. I got to talk to my customers. I got to talk to the business. How in the world can I sit down and write code? Because if I take up programming, if I start writing code, I will never be able to complete it because there are so many things going on that puts me in all directions. Well, sure. But one thing I've learned over in my life is when I am absolutely motivated to do something, I am not going to give excuses. Nothing will stop me from doing it. But if I'm not really committed to do something, I'm going to discover more excuses. So the point is this. I don't have to code full time. As an architect, I can go sit next to a developer and say, hey, I've got 2 hours every day on my calendar cut out for just coding. I don't have to code for 2 hours alone because I won't be able to finish things in the 2 hours. But in that 2 hours, I'm going to have it on my calendar, do not disturb. I'm going to sit next to a developer and code with them. Tomorrow I'm going to go to another developer and pair with them. And I keep rotating my pairing with developers just 2 hours a day. What a difference it can make compared to what we do today. That can make a world of difference. And then we can lead by example by saying, oh, you know what? I know how this stuff works. Let me show you how this works because I can bring my experience, combine it with the knowledge of the coding, and we can get better doing it. And that's definitely beneficial. So a good architect practices what they preach. So they absolutely have to practice. They've got to be hands-on. We can't just tell people to do and get away. That's not for architects. We have to be a lot more hands-on to deliver that result. Write code. I can't emphasize this. It's kind of scary because I go to some companies. When they say I'm an architect, what I hear is architect means I don't code anymore. That's not a good definition of being an architect. So if somebody, I go to a lot of companies where I work with architects and they tell me the words like when I used to code. I shudder when I hear that. Because if you're an architect and you say when I used to code, what are you making your decisions on? How could you influence your team? Whether Angular is a better choice or React is a better choice or it should be Vue or Preact without knowing anything to code about JavaScript, for example. So the point is, we can be effective in leading a team when we are not capable of really creating these solutions ourselves. So to be able to write that code is absolutely critical. And I would say avoid being a PowerPoint architect. This is the worst kind of architect, but unfortunately the world is filled with these people. They would use PowerPoint. If you ask them, what's your tool? They say, what do you mean? And then they show you PowerPoint, right? And the more PowerPoint we use, the more dumber we become as time goes on. And this becomes really scary. And they do all these beautiful pictures and they quit before anything useful gets done. So two things I recommend people. Avoid being a PowerPoint architect and avoid a PowerPoint architect. You can remove the word being there for a minute. So both of them are true actually. And we should really be practitioners in that regard. And one of the key things about this is, I'm going to say that every technical decision has an expiration label. Now, this is where we all are influencing technology decisions, but when we make these decisions, we need to clearly put a timeline on it and say, this decision expires on 15th of June, and we have to reconvene to evaluate it again. But in some companies, especially the one I talked about where they had these 50 architects who are holding the fort, defending a technology that was way back in terms of expiry date. Now, if you have architects like that in your company who refuse to think, I got a suggestion for you. Buy a can of milk in your house and keep it in your fridge for about 2 months. Don't open it. And then take it to work and go to the design meeting. And when they are telling you how design should be done, take a glass and pour this milk into it. You'll hear the cluck, cluck, cluck. And then you say, that's for you. And that, I think, will metaphorically convince them what they are trying to do. And their decisions are much worse than the milk carton that you have brought from home, which has not been open for 2 months. Well, that's exactly the point. We have to really reevaluate it in a timely manner, and these decisions expire. We cannot, in our field, hold on to knowledge from the past. We have to reconvene and evaluate whether that's still relevant, and we have to really examine and make fresh decisions along the way. And the last thing I want to mention here is to evolve the architecture. Now, when you get hired to do architecture, there's a pressure in our mind. I have to deliver architecture. What if you go to your boss and say, I am not going to develop architecture yet? Well, that takes courage because they're going to look at us and say, wait a minute, we hired you to do this stuff. Why are you not doing it? Well, how about saying, I don't have any clue? Well, that'd be really courageous, but true as well. You know, I used to work for a person, and he used to use the word RAD. And I used to think RAD stood for Rapid Application Development. And he corrected me. He said, RAD stands for Requirements After Delivery. And that is so true, isn't it? If you define what your requirements are after you deliver the product, you're 100% correct. Well, the point is when we start developing an application, we don't have a clue. We may pretend we do. Now, here's the funny part about what we do. We are told to create architecture. We are told architecture is important. We are told not to get it wrong. And then we are told to create it when we have no clue what we are doing. And this is called being predictably irrational. What if we can put a percentage of confidence in what we do? What if we say, hey, here's an architectural vision, but we got 10% confidence on it. And as time goes on, as we get better understanding of what we are developing, we are going to put more confidence into it. So confidence in architecture should increase with knowledge of the application. The more we learn about the application, the more we can become confident with the architecture we create, and the less we know about it, we need to lower that confidence as time goes on. But how do we really get better with this architecture as time goes on? One approach for doing this is the tracer bullet approach. Now, what is the tracer bullet approach? It's really funny. We are, as humans, really geared towards feedback cycles. We may be in denial about it in a lot of cases, but that's what we do. For example, if you ask me to walk from here to the end of that room, I'm going to be walking in a straight line. I'm not drunk. I'm pretty, aware. I'm not sleepy. I'm going to walk in a straight line. But if I blindfold myself now and walk right there, I have almost zero chance of hitting my target over there. I'm going to bounce off the corners. Why? Well, the reason is the human mind is one of the most wonderful, powerful tools we have. We constantly apply this feedback. We do this every single day. There's a homeostasis. We balance and we know to correct ourselves because the feedback loop is giving us. Well, that's exactly true for a lot of things we do. It's kind of funny, but I was reading about the automobile industry where they want to design wheels, and their turnaround time for designing wheels was about 3 to 5 months. And the reason is they would come up with these beautiful design and they would send the design specification for fabrication. And a few months later, they would come back and say, here you go. And usually 10 minutes later, it's like, oops, never mind. And they would redo it. Well, those people now are having a blast because they're not spending 3 to 4 months with fabrication. They are sending this to a 3D printer. And the 3D printer is taking a few hours to print their prototype. And they look at it and say, never mind. And they just redesign it. And that feedback loop is unbelievably powerful. Well, and the reason for this is we as human beings thrive on what's called an observer effect. An observer effect is when we see something, we want to change it. We do this a lot in software. We build something, we look at it, and immediately we want to change it. And we say, you know what, that's not really what I thought it should be. Oh, that sucks, let me change it. And the more we can enjoy this feedback loop, we can get better at it. But the question is, how do we really do that in architecture? Because architecture seems to be this abstract thing. How do we really get our hands on this architecture? Well, that's where the approaches like Tracer Bullet can come in. So what we can do is you come up with this vision of the architecture, but you don't implement every single component, every single part, every single layer. Instead, you put in place literally stubs or mocks in place. Now, these stubs or mocks are at a layer or architectural boundaries. They will receive some input and give fake responses, but you don't implement them until you realize your functionality cannot work without bringing the implementation. As time goes on, if those things are needed, you can replace those mocks with real implementation. And if they're not needed, you can throw them away. Hey, work not done is the best way to be productive, isn't it? So why waste the time doing that when you don't really have a need for it? Well, this is exactly kind of the approach of Tracer Bullet, is you get a feel for this by getting that feedback mechanism. Well, obviously the Tracer Bullet approach really is in artillery. If you're trying to shoot at something, if something is a target that's moving, if the person shooting is moving, it's really hard. But the Tracer Bullets can give you a trace of where it's going, and the human mind can immediately calibrate and you can adjust it. It becomes a lot more effective than doing all the math about it. So this is kind of the approach we can bring to architecture to get that feedback loop. So we talked about several different things over here that we can do to become better architects. We talked about be a mentor, not a tormentor. Criticize ideas, not people. Guide and don't dictate. Practice collective ownership. Don't be too much of a specialist. Be as much a generalist as you can be a specialist. Allow developers to figure things out. Focus on the outcome rather than the process. Gain domain expertise in addition to technology expertise. Learn to unlearn along the way very decisively. Diversify your knowledge portfolio. And learn, lead by example. Write code as an architect and evolve the architecture as time goes on. And put a percent of confidence you have in it and evolve it as your understanding of the application becomes a lot better. Hope that was useful. Thank you.
Are you joining us after, or do you have?
I'm joining after, yes.
Okay, so I sent Zeddy over to